So now we will start a new topic, right? The concept of the phase, very important, or the SHM as a projection of particle performing uniform circular motion, right? Listen one thing, we can think the SHM as a motion, as the projection of the uniform circular motion if a particle is doing uniform circular motion. For example, suppose if this is a circle, right, and this particle start doing motion on the circle like this. Are you getting or not? Now if you take this screen and you incident the light from this side, is it clear or not? So what will you get? You will get the projection, right? Suppose this is the x-axis, the particle is performing uniform circular motion and the speed is v, and the radius of this circle may be assumed to be a, right? The radius is what? Say a. All right, so listen one thing, when the particle is at this point and you incident the light, you can assume this is to be the screen which is equal to the x-axis, right? The screen is placed on the x-axis, you can assume. So when at t is equal to 0, if particle start from here, so its projection will be moving in this direction or not, you tell, right? After some time the particle reaches to this point. So when the particle reaches to this point, the projection is moving in this way. After some time the particle reaches this point, so its shadow, that is its projection, is moving in this way. When the particle reaches at this point, right, and this is the radius a, this is x is equal to 0, this is x is equal to plus a, the particle on the circular motion, performing circular motion, is moving in this way. So its projection speed in the x-axis is what? So its speed become 0. Are you getting or not? So if the particle is moving in this way, its shadow is moving in this way on the x-axis. Particle is performing circular motion, but its shadow is moving linear SHM like this. When it come to this point, so its projection start moving in opposite direction. When it come to this point, its projection is moving in this direction. When it come to this point, its projection start moving in this direction. Is it clear or not, you tell, right? So if the particle is performing like this, it is moving in this way, projection is moving in this way. It is moving in this way, the projection start moving towards left. When it move to this way, so its projection move in this way. Are you getting? When the particle is on this point, so its velocity in this direction become 0, right? And now the particle complete one revolution on the circular path, so its shadow move to this point and come back to this point. All right, so if the particle is performing uniform circular motion like this in complete one circle, the time is what? Suppose the t. So in the same time it is moving like this, going to right, it is moving like this, coming to left to the mean position, like this, it is on its original position, it come back to its mean position. Are you getting or not? So what is happening? It is moving round and round, its shadow is moving horizontally, left to and fro about this mean position. Is it clear or not? Suppose the special case I am talking, at t is equal to 0, particle start from this position. So after time t, it reaches to this point, right, and it complete the angle theta, right? So can you tell me, in the same time, what is the displacement of the particle you tell? This is the displacement, this is the x. If this is the amplitude A, so can you tell me what is the sine theta in this triangle? The sine theta in this triangle is what? Tell me. X upon A. So x is equal to what? Say A sine theta. If time period is t, so angular speed is 2 pi by t. And what is the theta? After it is t is equal to 0, at t is equal to t, it reaches to the point P. So theta is equal to omega t. So if its shadow start its motion from t is equal to 0 from the mean position, at t is equal to t, the displacement become x is equal to a sine theta. And what is the theta? Theta is equal to a sine omega t. So what is this? This is the displacement of the shadow. When particle moving in an arc, the displacement of the shadow is x. So this displacement is a sine omega t, and you know very well from the previous discussion, this is the displacement of SHM. Are you getting or not? Right. So therefore, when a particle perform uniform circular motion, right, clockwise, its shadow perform simple harmonic motion on a straight line, or linear SHM it perform, right? Its displacement is x is equal to a sine omega t, right? And you can find the velocity also. This is the velocity and the acceleration by differentiating this once again, right? Copy this. So you may write, if a particle is moving on a circle, on a circular path with uniform speed, right? With uniform speed, right? Then its shadow, then the motion of its shadow mean foot of the perpendicular is SHM. What is the foot of the perpendicular? This is the particle, so this is the foot of the perpendicular, right? If you draw the perpendicular on this line, so this particle is performing SHM. It start from here, then go, then like this, right? Like this. So it is performing SHM. Are you getting or not? So this is the one thing. The another very important thing, what is phase? Yes, what is the phase? If it start from here, this is the special case, it start from at t is equal to 0, the mean position is at x is equal to 0. So what is the equation is of displacement omega t? Can you tell me what is the phase in this equation? This is the phase, right? So this phase is nothing but theta is equal to omega t. So in this circle, right, the phase is nothing but this theta. This theta is nothing but phase. Are you getting or not? Here the theta is omega t after time. So the angle made by this line with the vertical in clockwise sense, this angle is called, this angular displacement is called the phase. Are you getting or not? First copy this, then I will give some examples. So we are discussing the motion of the foot of the perpendicular or the shadow of the particle performing uniform circular motion, right, is called the SHM. Listen one thing. It is not necessary that particle always start its motion from mean position. For example, suppose the particle in the previous case, the particle at t is equal to 0 start from here. If this is the initial position of the particle at t is equal to 0. Are you getting or not? So after some time, t is equal to t, the particle will displaced initial initial angular displacement is phi already present. So after time t, it move further angle theta. Are you getting or not? And what is the theta? Say omega t. Therefore, if you draw its motion, so at t is equal to 0, the particle is at this point. Are you getting or not? And after time t, the particle reached to this point. Is it clear? It is at t is equal to 0 initial, and after time t, the particle reached to this point, right? And it is performing uniform circular motion. Is it clear or not? So you tell me. At t is equal to 0, particle start at this point and then it move this, right? It goes like this. It perform uniform circular motion on the circle, and its foot of the perpendicular will perform linear SHM on the x-axis. Is it clear or not? So this phi, now if you want to find, this is the phi. If you want to find, this is the initial displacement already present. So can you find this x? Yes. If this is a, the radius is a, now you can write sine theta plus phi. Sine theta plus phi is equal to perpendicular upon, right, hypotenuse. So x is equal to what? A sine theta plus phi, right? And what is the theta? Theta is omega t plus phi. Is it clear or not? Listen one thing. This angle phi plus theta, this is called the phase. What is the phase over here, you tell? It is omega t plus phi. Is it clear or not? And what is the initial phase? The initial phase is phi. The initial phase mean the phase of the particle when it starts its motion. When it starts its motion, what is its phase? The initial phase is phi. And this is the phase omega t plus phi. When we started the SHM, I told you the SHM is defined as, if the acceleration is proportional to minus x, it is equal to minus omega square x, d square upon d square plus omega square x. This is the second order differential equation, and its solution of this differential equation is given by a sine omega t plus phi. Although there is a mathematics, you will learn in the mathematics, right, how to solve this differential equation in differentiation integration chapter in your mathematics, right? So this is x is equal to a sine omega t plus phi. But this differential equation is very important. It will appear many times in class 11th and class 12 in the different way, right? So you will remember this is the differential equation of SHM, and its solution is a sine omega t plus phi. Then at that time I told you this is what? This is the phase. And what is phi? Phi is the initial phase. Is it clear or not? For example, listen one thing. If this is the circular, if you consider, although we have to consider the particle performing SHM on a straight line, but the concept of the phase, it is very tough. So we will relate the phase to this uniform circle, right? Circular motion. For example, if the particle start its motion from a by 2 at t is equal to 0. So what is its initial phase? If particle start from here, so its corresponding particle on the circular path will be at this point. So at t is equal to 0, the point on the circle will be here, and it is performing SHM. So at t is equal to 0. So you have to find the initial phase. Initial phase mean the angle made by this vertical line to this vector. So what is this phi? So if this is what? This is a by 2 distance. This is also a by 2 distance. This is a. Are you getting or not? So what is sine phi here? Is equal to perpendicular upon hypotenuse. It is sine pi by 6. So what is the initial phase here? Say pi by 6. Is it clear or not? So the initial phase is pi by 6, and after some time it will move t is equal to t. So it will perform, it will subtend some angle theta which is equal to omega t. So you can write the equation of this particle. Equation of this particle is what? X is equal to A sine omega t plus phi. What is phi? A sine omega t plus pi by 6. Is it clear or not? Copy this. So we solve some questions, right, to understand the concept of phase. For example, listen one thing. You tell me, if the particle starts its motion, what is the phase? The angle made by this vertical line in clockwise direction is called the phase. You tell me, if particle is over there at t is equal to 0, so what is the phase? What is the phase at this point? Tell me. Say 0. What is the phase? Tell me, Varsha. 0. So when it complete half of the 1/4 of the circle, when the particle reaches this point, what is the phase at this point? Tell me. What is the phase? Pi by 2. So it means when the particle is at mean position, so what is its phase? Say 0. When it reaches to the right extreme plus A, like this. So how much phase it covered? At this point, the phase is what? Say pi by 2. When it moves further at this point, when particle reaches at this point, so it will come back to this point. So what is the phase at this point? You tell. This pi by 2 further pi by 2, suppose this is further pi by 2. Tell me, what is the phase when it come back to its mean position? Pi. Very good. So when it move to the left extreme, right, over here suppose, so the particle reaches, corresponding particle on the circle again cover the phase angle pi by 2. So what is the phase over this point? 3 pi by 2. When it reaches to the mean position again like this, so when it is moving in this way, so what is the phase of this particle? Say 2 pi. Are you getting? So in one complete circle, what is the phase obtained? It is 2 pi. Is it clear or not? Right. So the angle made by this vertical line is phase. Is it clear or not? For example, listen one thing. If particle start, suppose, for example, I am giving this side. If this is plus A, this is minus A plus A. Are you getting? This is x is equal to 0, right? If the particle start its motion from x is equal to root 3 times of A, this distance is root 3 times of A, and it start its motion over here. Are you getting or not? And it perform SHM like this. So can you tell me what is the initial phase over here? Initial phase. Yes. Copy this first, then I will give you 1 minute to think about this. In this question, find initial phase of the particle. Initial phase of the particle. It start its motion at t is equal to 0. The particle start its motion from x is equal to root 3 by 2a. Right? Copy this. So let's see this question how to solve. Right? Although there are mathematical solution of this question, but we will solve this question with the help of the circular motion, right? Like this, right? The particle starts its motion and it is going in this way, right? So you tell me, if it is a by root 3, a root 3 by 2, right? So this is the initial phase. That's it. Very simple. It is a root 3 by 2 distance, right? T is equal to 0. So what is the sine phi? Sine phi is perpendicular upon hypotenuse. It is root 3 by 2. It is equal to sine 60 degree, pi by 3. So what is the initial phase? Say pi by 3. Is it clear or not? Right? That is the thing. Other solution, which is little bit tough in different situation. For example, the method 2. This is, you can write the method 1. So you will compare x is equal to a sine omega t plus phi. Are you getting or not? What is the x? At t is equal to 0, what is the value of x? You tell. The x value is root 3 by 2a is equal to a, and put t is equal to 0. Right? A will cancel out. Root 3 by 2 is equal to sine phi. So what is this? Sine pi by 3 is equal to sine phi. So initial phase is pi by 3. Is it clear or not? But it will not work every time, right? The correct method, and when the question is tough, this circle problem, right? This circle will help you to find the initial phase. Is it clear or not? Listen one thing. The question was find the initial phase. Also write the equation of SHM. Equation of SHM. So once you found the initial phase, and suppose the amplitude is a and the angular velocity is omega, right? Angular frequency is omega. So what is the x is equal to a sine omega t plus phi, right? Because phi is already present. So after some time t, right, it will continue to move in this way, right? So what is that? This is the general equation of the displacement of the equation of SHM, sine omega t plus pi by 3. That's it. Are you getting or not? Listen one more thing. If you remember, if the particle starts its motion from x is equal to 0, in the previous lecture we have taken a special case when the particle starts its motion from mean position at t is equal to 0. So here the initial phase is 0. That is why we always write sine omega t plus phi, and this phi is 0. So x is equal to a sine omega t. Is it clear or not? So this is only the special case when the particle starts its motion from the mean position and moving towards positive x-axis. Is it clear or not? Otherwise, if the particle starts its motion from other point other than mean position, there would be some initial phase, and you have to write the general equation in this way. All right. Copy this first, and I will give you few more examples. So let us take few more examples. Right. Listen. If a particle starts its motion from the positive extreme, right? The amplitude is a, angular speed is omega, right? The particle at t is equal to 0, right? If particle starts its motion from plus a, from positive a, find its displacement equation, right? Displacement equation. Can you do that? Copy this and tell me the answer. So you can solve this by phasor diagram. What we call this is the phasor circle, right? It is at this point. The particle start at t is equal to 0. So what is the initial phase already present? Say pi by 2. So its initial phase is what? Say initial phase is pi by 2. So what the equation you will write for the displacement? A sine omega t plus pi by 2. And a omega t plus pi by 2 or sine pi by 2 plus theta is what? Say cos theta, if you understand. So it may be written as a cos omega t. Are you getting or not? So this is also the equation of SHM. Although I tell you only the equation of the SHM is a sine omega t plus omega t, like that. But it may be some phi also. So if the phi is pi by 2, so what is the equation of SHM? Say x is equal to a sine a cos omega t. So you can think like this. If this is equation of, right, 2 pi by t into t. So when you will put t is equal to 0, so initial displacement is what? So initial displacement is a. So that is why at t is equal to 0, what is the initial displacement? A. So if the particle starts its motion from right extreme, what is its displacement? What is the displacement equation? X is equal to a cos omega t. Now if they ask the velocity, what is the velocity? Say dx upon dt. The velocity is a omega, right? Its differentiation is what? Dx upon dt is equal to a minus omega sine omega t. So what is the velocity? Is equal to minus a omega sine omega t. So this is the velocity of the particle performing SHM. Start its motion from positive extreme. If you want to find the acceleration, how to find the acceleration? dv upon dt. Again differentiate, minus a omega, differentiation sine omega, it is cos omega t. So this is the equation of the acceleration, like this. Is it clear or not? You tell. Varsha, please tell. Listen one thing. If in the another question they say that the particle start its motion from negative extreme. Tell me, if particle starts its motion from minus a, right? From minus a, left extreme. It means the particle is at this point. So can you tell me what is the equation of SHM displacement? A sine omega t plus phi is the general equation. So if the particle is starting its motion at t is equal to 0, particle is present at x is equal to minus a. So it means it has covered already this much phase. What is this phase? Can you tell? 3 pi by 2. So what is the initial phase? Say 3 pi by 2. So what the equation you will write? A sine omega t plus 3 pi by 2. Are you getting or not? You tell. So in this way, if the particle is other than from mean position, right? So in this way you can write the different equation of the displacement, then velocity, then acceleration. All right, copy this first. So listen one thing, one more example. If particle is at mean position, right? Particle is at mean position and going towards negative x-axis. Find its displacement. Equation or only the displacement, you can say. Understood? What is that? If the particle is performing SHM, the amplitude is A, it is the mean position, but at t is equal to 0, the particle is at mean position, but it is going towards negative x direction, right? You have to find its displacement equation. Copy this question and try this. Let's see how to solve this question, right? You can make the corresponding circle. Tell me, if the particle is moving in this way, so where the corresponding particle on the circle, the corresponding particle of the circle is at this point, because when it is moving, so it is going in this direction. So this phase is already present, and which is equal to simple pi, right? So if the particle is at mean position and going towards negative x-axis, so what is the equation of the displacement? Say a sine omega t plus phi. So what is the initial phase over here? The initial phase phi is equal to pi. So the answer is a sine omega t plus pi is the differential equation of displacement, and sine theta pi plus theta is equal to minus a sine theta, you can write, right? So this is the displacement of the particle performing this type of SHM. Are you getting or not? Copy this. So let us take one more example. Suppose this is the straight line. The particle is performing SHM. This is the mean position. If this is the a by 2 and this is minus a by 2 position. This is the particle 1 going towards this direction. This is the particle 2 going in this direction. This is the particle 3 going in this direction. This is the particle 4 going in this direction. Right? It may be something. Right? If a t is equal to 0, right? First do this question only. Right? These are the two particles. If particle starts SHM, it's SHM from x is equal to a by 2 at t is equal to 0. Right? If I am writing the question, if particle start SHM from x is equal to plus a by 2, find its equation if, right, first it is going, if it is going towards positive x direction, second negative x direction. This is the first particle, this is the second particle. So you have to find the equation of SHM, right? Copy this. So how to solve this question? By making the corresponding circle. Although there may be some mathematical solution of this, but it is better, it looks better, right? If the particle is, you tell me, it is at a by 2, right? The first a by 2, are you getting? This is the at a by 2 and it is going in this way. So where is the corresponding particle on the circle? Tell me, this is 1 or 2, you tell. Tell me, which particle should I take? This is the a by 2, right? And it is going towards positive x direction. So it is this. So which particle is corresponding on the corresponding particle on the circle? First or 2? 1. Because it is going in this way, right? So here, if this is a by 2, so what is the initial phase for this particle? Leave this. So its particle start its motion from here. So corresponding particle on the circle is 1, and this distance is what? Say a by 2a. And what is sine phi then? A by 2 upon a. And this is 1 by 2. It is sine pi by 6. So what is the initial phase? Say pi by 6. That's it. Are you getting or not? So what the equation I will write? What the equation? For this, the equation is a sine omega t plus pi by 6. This is the one solution, first solution. Now in the second part, suppose the particle is at x is equal to, tell me, a by 2 over here, and it is moving in this direction. So corresponding particle will be either this or this. So I think you must bet, you may know, right? This is the second particle over here. So can you tell me, what is this initial phase? Should I write? Repeat. Pi by 6 plus pi by 6. Yes, pi by, no. How it is? Listen, one thing, if this is a by 2, this is a by 2. So this angle is 30 degree, pi by 6. Are you getting or not? This angle is pi by 6. So what is this phase? What is the phase phi? Please tell. This angle I am asking. Repeat. 2 pi minus pi by 6. How it is 2 pi? Please tell. How it is 2? Yes. Pi minus pi by 6. Is it clear or not? You tell. This angle, suppose the corresponding particle on a by 2 is over here. So if this is a by 2, so this is pi by 6. This is also a by 2 for this particle. It is a by 2. This is pi by 6. I am asking, this is the phase for this particle. So the phase is pi minus pi by 6. So it is 5 pi by 6. So initial phase for this particle number 2, when it is start its motion from a by 2 and going towards negative x direction, the phase is, right, pi minus pi by 6, 5 pi by 6. Fine. So what is the equation of SHM? X equal to equation of displacement omega t plus 5 pi by 6. Is it clear or not? You tell. Right? Copy this. So now if the particle start, this is plus a minus a, all right, and the particle, one particle is going in this direction and one particle is going in this direction, and this is the displacement minus root 3 by 2 a, right? This is the first particle, this is the second particle. First particle is going towards mean position, it is away from the mean position, right? Find displacement equation for particle 1 and 2, right? Try this. For this question, make the corresponding particle on the circle, right? This is x is equal to 0 minus a plus a. For second, first of all, the second particle is present at this point, minus a root 3 by 2. It is clear? Fine. So you tell me, if you want to draw the corresponding particle on the circle, which is the point? Suppose this is the second particle, it is going in this direction. Tell me, which particle is the corresponding particle, 1 or 2? For this particle, which is the corresponding particle on the circle? Repeat. 2. Very good. 2. It is very simple, not very tough. If this is minus a root 3 by 2, so this distance is what? A root 3 by 2. Right. So for this particle, what is the initial phase? This is the initial phase. So to find the initial phase, can you find this angle alpha first? If this is the A, what is the sine alpha? Tell me. Sine alpha is equal to perpendicular upon hypotenuse, root 3 by 2. Sine alpha is equal to sine pi by 3. So alpha is equal to pi by 3. But the initial phase start from here. So particle is at t is equal to 0 at this point. It start SHM from here. So what is the initial phase? Phi. Please tell. Varsha. What is the initial phase here? No. Pi plus pi by 3. Right. You are correct. Pi plus alpha. Right. So pi plus pi by 3. It is 4 pi by 3. Is it clear or not? You tell. Right. So this is the phase of the particle 2. You can think. Right. Now, if we want to write the equation is simple, sine omega t plus 4 pi by 3. Is it clear or not? You tell. Right. So this is the equation for the second particle. What is the phase for the first particle? Tell me. For particle 1. Can you repeat? Right. And further simplified, if this is alpha, listen, this is alpha, this must be alpha or not, you tell. If the particle is going right in this way, so its corresponding particle is present on the circle here, and this is a root 3 by 2, this is a root 3 by 2, alpha is what? Alpha is same 4 pi by 3. Getting or not? Sorry, alpha is pi by 3. So what is this? This is alpha. The particle is 1 over here. This is alpha. So what is this phi? You tell. Phi is equal to 2 pi minus alpha. And what is the alpha? Say 4 pi by 3. So 3 दूनी 6, 2 pi by 3. Wait for 1 minute. 2 pi minus pi by 3. Right? Alpha is what? Alpha is pi by 3. So this is what? 5 pi by 3. Is it clear or not? Please tell. So this is the initial phase, right? And the particle is moving here, right, in this direction. And this is present a root 3 by 2, right, from mean position. So what is the equation of SHM you will write? Is equal to a sine omega t plus 5 pi by 3. Is it clear or not, you tell? So this is the equation. Fine. Copy this. Okay, one more thing. Tell me, if this is the one particle, this is the another particle. What is the phase of this particle to you tell? The phase of this particle is 4 pi by 3. The phase of one particle is what? 5 pi by 3. Is it clear or not, you tell? So for this phase, phi 1 is 5 pi by 3, and for this particle, phi 2 is 4 pi by 3. So what is the phase difference? Tell me. The phase difference. Also you tell me which particle has a more phase. Which particle has more phase? Particle 1 or 2? 1. And what is the difference? What is the difference of the phase? Yes, listen one thing. This is the difference in the phase. Only this is the difference in the phase. Is it clear or not, you tell? So, although you may find the difference from here, 5 pi by 3 minus 4 pi by 3. So, the phase difference between them is pi by 3, and particle 1 is ahead to the particle 2 by phase. Tell me, pi by 3. Is it clear or not? Look at the figure, right? These are the two particles. This is pi by 3, this is pi by 3. It means this is 60 and this is 60. So what is the phase difference? This is the phase difference. Pi by 3, what is left? Delta phi is nothing but pi by 3. Is it clear or not, you tell? Right? So in this way, with the help of this circle, they may ask the question in this way. If the particle is present minus root 3 by 2a and moving towards positive axis, moving towards negative x-axis, what is the phase difference between them? So, right. So in this way you can find. Copy this. In this question, you can read particle start from mean position and move towards positive extreme. So if this is the plus a, this is the minus a, it will start from here and start from positive extreme. So what is the initial phase over here? You tell. 0. So the general equation is nothing but xt plus omega t plus fine. So a sine omega t plus 0. So what is the equation of the displacement? A sine omega t, simple. All right. In the second part, similarly, yesterday I told you, right, if the particle start at t is equal to 0 from the mean position and start towards the negative, right, x-axis. So what will be the phase for this particle, you tell? Yes. Varsha, what is the phase for this particle? No. Let me check and tell me correct. The corresponding particle of the circle. Where is the corresponding particle on the circle, you tell? Repeat. Pi. Is it clear or not? Listen one thing, when it go to this point, what is the phase at this point? Pi by 2, right? reaches from here to here, right? And when it come back to this, what is the phase? Further pi by 2 and further pi by 2. The particle reach at this point, right? So here the phase is what? Say pi. So phase is pi. So what is the equation of the SHM for this particle utal? Sine omega t plus pi. You understand this question or not, utal? Copy. So what is the question utal? If this is the A, right? This is plus A, this is minus A. And at t is equal to 0, particle is where? Say it is at distance A by 2 and it is moving towards mean position. Are you getting? So read this question. In this question, the particle is present at A by 2 and it is moving towards the mean position. So where the particle on the corresponding circle, right? On the circle, where the particle will be, utal. This is the line. This is the foot of the perpendicular. So particle is at one position or at two position utal? It is at two position. So this distance is what? This distance is A by 2, right? This displacement, and this is itself A. So what is this angle? Sin alpha is equal to what? Perpendicular upon hypotenuse. It is 1 by 2. So sin alpha is equal to 1 by 2, alpha is equal to pi by 6. But the phi is what? It start from here. This angle you have to rotate it. So this is the phi. So what is the value of phi? For at t is equal to 0, the initial phase of this is pi minus alpha. Pi minus pi by 6. The answer is 5 pi by 6. Right? So what the equation of the SHM for the displacement you will write? A sine omega t plus phi. This is 5 pi by 6. Right? This is the displacement. Copy this. Let me do this. The time period is what? 2 seconds in this question. The maximum displacement is what? Say 5 centimeters. So it is amplitude. So the omega you will write 2 pi by t. 2 pi by 2 is equal to pi second, pi radian per second. Fine. So also at the start mean at t is equal to 0, the particle is at maximum displacement on right side. So at t is equal to 0, here what is the phase utal? Repeat. Pi by 2. So x is equal to what? A sine omega t plus pi by 2. Right. The amplitude is 5. Right. And sine omega is pi t plus pi by 2. So the answer you are writing cos pi t is the equation of the displacement. I think you understand this. Copy. So read this question. In this question, the equation of the motion of the particle performing SHM is 0.5 pi t like this. The point move from position of equilibrium to maximum displacement. From equilibrium to maximum displacement. Yes. Tell me, the maximum displacement is 7 centimeters suppose. What is the time? Listen one thing. If, although I have told you the equation was A sin omega t type, but if it is A cos omega t type, then what does it mean? What does it mean? Yes, phase already present. The particle is not starting from here, rather it start from here. At t is equal to 0, particle is at 7 centimeter. But it is does not matter what is the time period. Time period will be the same, right? There is no difference in the time period. They are asking the time period. What is the time they are asking? From mean position to extreme position, or extreme position to the mean position, the time is same. And what is that time? Say t by 4. So how to find the time? Is equal to t by 4. Can you compare with omega t? A cos omega t. The omega is what? Say 0.5 pi. So there is no difference in the omega, whether the particle start from this point, from this point, from this point. But omega is the omega, it means time period remains same. The initial phase may be different, but the omega is okay and no change in that case, right? So t is equal to 2 upon 0.5, right? It is 4 seconds. So time period is 4 seconds, right? So 4 upon 4 is equal to 1 second. What does it mean? It means the particle takes from mean position to equilibrium or equilibrium to mean position. The time taken is 1 second, right? Copy this.